Hello, everyone. My name is Philip Cwynar. I'm an ML engineer at Accelerant Holdings. I come with about 20 years of software experience, business process redesign, and data warehousing, and probably about the last 5 years machine learning engineering.
Yes, my name is Sajad Alabadi. I'm ML engineer working at Accelerant. It's been like 1 year with Accelerant. I used to work as a principal data scientist for a fintech company for like 2 years, and then oil and gas. So I have the data science experience and the ML engineering experience with building ML models and push them to production. Yes.
Okay, so why are we here? We're here to talk about probabilistic data document routing with schema drift conformance. To kind of simplify that, we're going to say classify, conform, and route. So just to give you an outline of our work, want to be able to give you the area of our work, our problem description, our data set, and our subject matter expert engagement, and our design pattern. So it seems like in the insurance industry, we're all dealing with messy data. On the left side here, you can see that we have a lot of raw data files. So these are our insurance documents from many members that we have. So we have a lot of insurance companies that we are partners with. So they have a lot of variety in their data. So when we look at the left side here, what we're trying to do is we're trying to get this chaotic outside world of data inside into our traditional business processes now. So to kind of piggyback on Alejandro, this is not just technology, this is not just business, this is business process added with technology at critical points to enable contemporary kind of data warehousing. So we're trying to get the data in. So on the left side, we're looking at the raw data. And so it's pretty cool and exciting tech with hard problems. All right, so we're using machine learning, different types of document processing, different libraries for file extraction, lots of stuff. We're in the jungles. After we get through raw, it's basically our traditional business process. You can go out there and you can talk to an Informatica rep, and they're going to do the mappings and everything like that. Outside's hard, easy stuff's inside is kind of easy here. So to not shine a laser pointer at you, we'll click the next button, and so we're going to go on. So if everyone's familiar with big data, we have the 3 V's. Sometimes there's maybe 4, but we'll deal with the 3. We have volume, velocity, and variety, and our problem is variety. What is that? Our definition of variety is we have many diverse document types and diversity within the same document type. So, we have apples, we have types of apples, we have Granny Smith, we have Red Delicious, but we're going to call them an apple and we're going to categorize them together. We have oranges, but we got to separate everything out. But there's diversity inside of, the apples, there's diversity inside of the oranges. So how do we deal with that too? So our main problem we have 2 problems with our sorting, or with our variety. It's sorting and storing. So everybody knows that, these are traditional problems throughout time with our industry. So we have to sort the data and we have to store it. And to store variety is a pain. Okay, so the last maybe decade, everyone was talking about NoSQL. You don't need to do that anymore. We have techniques available to us now that we're able to kind of store this data in the natural flow. So sorting and storing are our main problems. The sorting of the data, many document classes to define. So we have, within our members, we have different LOBs, we have different document types, we have written, we have exposure, we have claims. So we need to understand the similarities and uniqueness. We need a common naming convention in nomenclature. This storing, okay? Now, has anyone tried to ever store 2 different files in the same table with traditional BDMS technology? You're going to have a problem. You're probably going to get a phone call at night saying you got to fix something. You got to change one column and you got to make it look like the other column. And that's a human job because we're dealing with structured data in our past lives. Now we're dealing with variety and we're being the boss of variety. So So right now, what's our data set and what's our subject matter engagement? Because this is not a tech problem, this is a business problem. So the yin and the yang is the business and the tech, and together we come up with this contemporary business process. So we're going to talk about our terms here. Oh, sorry. With the subject matter engagement, our class definitions were defined by our subject matter experts. what was our data set? Historical bordereaux. So all of our business documents throughout our insurance members, so premiums, claims, exposure documents, and we worked with these subject matter experts to properly label and sort the file. So we did have a human in the loop. We had, this is essentially a supervised learning issue here. So this is how we developed our training set here. Now let's talk about the terms. Okay, so the terms in the probabilistic document routing configuration is base class, classifier, and the collection of the class. And this is the label is their common thread. So doing this exercise with the subject matter expert, domain-driven expert, they should be able to kind of tell us what's what to a certain degree. And then, we're going to have to kind of have a feedback loop. But for right now, we're going to go ahead and define these base classes with the subject matter expert. And we have our classifier. The classifier is trained on the definitions and the features extracted from all these documents that we had in our last slide from the data set that we used. And then our last piece is the collection. So we have our base class, we have our classifier, and we have our collection. So we have where our classes are defined, how our classifier handles them, and then where our classifier stores them. So kind of tie this together here. So this is our system here that we came up with at Accelerant to kind of do our probabilistic document routing and schema drift conformance through classifying our documents, conforming them, and routing them. So when we have a supervised learning problem, we look at our left side, our data definition. So that's how we label our data. Our data storage is how we persist our data. And then with our classification is how we kind of, we classify it. So with our labels, you can see that our base schema is our definition plus our class label. Our data storage is our location of where we're going to store that data plus the class label. So what we do is we have to have a file come in, we route it, or we actually classify what it is, and then we have to conform that incoming file to our definition. So we've got variety coming in, we have our definition, and how do we deal with that variety? It might not be that variable, but it might be a lot variable. And so this is how our classification engine kind of works through this here. So when let's just skip back one step here if I can do that. So with our classifier, we classify, and then we pick a base document to come out of here. So it's going to say this is a written premium document from member X. And as that comes in, we select that. We want to conform that. So how do we conform that? We have our base definition with basically our column. So this is a tabular representation. We have our columns that we're looking for. We check inside of the missing data for our missing columns what's not there. We're not doing an inductive search, we're doing a deductive search. And then what we have is our missing columns that we're actually looking for. And from within our wild set of data that comes in, our wild extra columns, then we have a conforming routine that is based off of a little bit of a fuzzy logic, and we have a threshold there. So we have our terms defined, and then the external variety data, variable data that comes in is conformed to our data. The schema merge is how do we handle the new columns is once we've once we've conformed the wild columns to our standard, there might be extra columns that we have in there. And so traditionally you were not able to store those because those would be considered a new entity type. But now with schema merge, we're able to add, so our conformed data set, incoming data set has column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now our base set really only has 5 columns because we're looking for them because those 5 columns support our core business financial reporting. That is our #1 driver for this. These columns here may be used for data science, maybe used to enrich the claims reporting process, maybe used to help, check out the exposure process because, in this raw data set, we're not cooking anything. The cooking's happening in the silver and gold layers as they move through here. So we're also creating a repository for data science to be done as well with these kind of extra columns being added on. And then the next piece is how do we deal with outliers with classes that we don't see? So a file comes in, we classify it, and it either comes with a low threshold or we misclassify it and it comes through and we do not merge that data because we don't want to undermine our data stores. So we have a few fail safes in if it slips through. But essentially, our business process is human in the loop. We have an exception UI for the business user to correct the label of incoming undefined document classes, and then we kind of send that through, they relabel it, and we retrain back on that. Basically, I think I went rather quickly, but I'm going to hand this off to Shazad.
Yeah, so I'm gonna speak a bit more about our models. Our models are smart enough, like to know the file type based on the column's name and based on the data of these files. We're dealing with lots of files, more than like 1,000 files coming from different members, different products. We have over 180 products, and we got like different files, zip files, like text, Excel sheet with multiple sheets inside, and we need to map all these files into something called core fields, which is basically it's our structure database where we feed our Power BI reports and feed the insight to the business. So we have lots of files coming like with group headers. I'm sure you guys are aware of this problem. Like we have like files and basically, let's say one file we get with 5, 6 headers, and we're not interested in the first or the second or the third header. Maybe we're interested in the fourth header here. So we have ML models that can identify the main headers for each file and trim the file and only extract the data we want and feed it into a structured database. Also, like our model is smart enough to find the data type. It's not like only a regular expression or like a syntactic dictionary. It's basically can know, for example, the name, the company name, the name, the address, the postcode, zip code. We're dealing with different countries. For example, in the UK they use zip code. In US they use in US they use zip code. In UK they use in US they use postcode and things like that. Also, will relate and understand the relationship between the labels for each file. For example, one column in one file, let's say it's a city, London, whatever, and the other file could be place of birth. So if we have different files with the same, let's say the data is London, let's say New York, whatever, how we can map these data into the core fields, how we can say, hey, this basically this column it should map to place of birth, and the other column should map to, for example, a city. Our model is smart enough to map all the data we're getting into what we call core fields. So, like, we use, deep learning to train our models. And we have like average F score 90, 89%, and getting and identifying the right labels for our models. Also, as I said, we have different files coming from different members. We have over like 60, 70 members, thousands of files. So we need to know, hey, this is a claims file. This is basically a written file. This is exposure file. Our models can detect that based on the data in these files. It also can take care of like, some sheets that like, with no data, sometimes you get like Excel sheets with 5, 6, 7 sheets and only you're interested in 2, 3 sheets. Based on the sheet names, can only extract the one we want and, get rid of the ones we don't want and convert that into a structured database where we do the transformation, and then we have another process of ML models to do the data quality and do the validations. All that built into pipeline, and we're getting usually the files through emails or SFTP link, and we process all these files at the same time, and we save it into a structured database. I think this is what we're doing at Accelerant, and if you guys you have any questions, like we're happy to answer.